Hi, class, and welcome back to the lecture on electromagnetism. I think this is part two, and the idea with this is what we're going to talk about is this different kind of thing called Coulomb's law. And Coulomb's law states that if you take two forces, so for example, let me kind of do this real quick here. If you take two forces, like maybe two electric currents, actually. I mean, we're not doing forces. We're kind of taking two electric charges. So if you take like two objects, or maybe that you take a proton and an electron, and they have a charge. Okay, so you have some kind of electric charge. And what this is doing is that depends on how strong the electric charge of both of these. And then if you give them a certain distance, they either attract or they can repel each other. And so this is kind of what we're going to discuss a little bit today. Is this electric charge and if these can attract or repel each other using Coulomb's law. So a little bit about Coulomb is that Charles Coulomb, about 1736 to 1806, he's a French scientist, physicist, engineer. He was interested in how charged particles interact with each other, and so this is kind of like what he was doing is that you have these two particles and you're giving them some distance, and all of a sudden as they get closer to each other, depends on this charge, they might separate very fast. And so if you think about it, if you take maybe a north and a north, like a magnet, you know what's going to happen, right? Because they are both the same charge, I should say, the same charge, because they're both north, they are going to repel each other very strongly. And that's the idea what he's trying to come up with, or that we're going to look at today. And so what happens is that it increases the charge as the charge increases. So when you're charging something up, you're building up electric charge into the molecules, right? And if you decrease the distance between them, so for example, if you take these two charged particles and if you put them at a certain distance, you increase it or decrease it, something's going to happen with the electric charges. And as you do the homework, you're going to figure, kind of what's going on when you have a charge on this one versus a charge on this one. Are they going to repel or are they going to attract? And you're also going to look at the distance between them. So here's kind of like a little picture here. And this helps you kind of describe. So then the thing is that you have these two charged particles. We call them Q and Q. And just because of different notation, because charged particles versus mass, we're going to talk about that in a little bit, about something that you should already know. It seems very similar to that we've done in the past. You do not want the charged particles to be the same. They can't be the same because then nothing happens. So you have these two charged particles. They're at a distance between each other. They're either going to repel or attract. The formula that you're going to be working with and you're going to be working on the homework with is this. And if you think about this, you probably already know another formula that looks very similar to this. And so I want to put it down here. You don't need to write this down if you don't want to. But if you think about this formula, it looks very close to what we've done in the past, is that it's force equals big G mass 1 times mass 2 distance squared. So if you think about Newton's law of gravitation, and then you have Coulomb's law that describes the two electric charges. So remember, these are two electric charges, and these are two masses. They're very similar to each other. And there's a relationship that I will ask you about these, and you describe the relationship between these two, which I pretty much gave it to you already. But here's all the information that you need for here. And so you're still dealing with a force because you're trying to take what's the force between the two electric charges. So you're still going to be in newtons. Q1 and Q2 is the amount of charge. Remember, the amount of charge depends on if they repel or not. The distance between them, which we still use meters. Then we have that gravitation. Remember back in the day, we did the gravitational constant, which was some number, right? I think it was 6.67 times 10 to the negative 11 power. But we're not doing that because we're doing electric charges. And so we're going to use what we call a K, which is a constant. And that number is 9.0 times 10 to the ninth power. Now, think about that compared to our gravitation. Gravitational force was smaller, very small. You can hardly notice that, but it was still there. This is so much bigger because electric static and charges really affect people. People get killed by electricity. And so there's a lot with electricity. If you think about it, it's very powerful with electric charges. This is why people get killed sometimes. It's like touching a wire or like has many volts. Okay, so let's go ahead and do a couple examples to kind of tell us like what's going on with this today. Okay, so here's your first example of this that I would like you to kind of write down as part of your notes. So I'm going to give you two charges. So here's your example here, your two charges. Okay, if you don't want to stop the video to write that down, please do. Okay, so you have one of the charge particles has this much, and the next charge has this much. Now, I want you to pay very close attention to is that this has a positive charge, and this has a negative charge. So you know that, okay, I have opposites now, so they're going to attract each other. Let's figure out the distance, though, between them. Let's put the distance of 0.5 meters, which is not very meters at all. Remember, 0.5 is, let's say there is, 100 centimeters equals 1 meter. And you can figure out how many meters that is, right? That's not that many. It's how many centimeters is that? That's 50 centimeters if you think about it. Okay, so you have 50 centimeters or a half a meter. Now, you have these two charged particles, but at a very short distance. So you're going to go ahead and jump to the equation or formula and be very careful after you put this in there. So let me kind of take this away. So be very careful as you're putting this in because your calculator will give you a weird answer. We talked about that, how to put the right stuff in the calculator. So this is your K number. So that K number is that. This is going to be your Q1, which is that one, and times the Q2, which is that one. And then below, you have your distance squared. Now, it's not radius. It could be radius. You can think about these. These are kind of like circles. You can kind of think about they are radiuses in a way. So if you think about this, if you call this r squared, I would be okay with that. It could be r squared if you want. This could be r. This just means distance between. But if you think about these are circles, they have a center, and as the center goes around, I mean they form a circle. And so we call r as radiuses, but just for our sakes, call them d. It helps a lot. They're just it's the distance between them. Okay. So if you put all this in the calculator, remember when you're multiplying this is multiplication. So when you multiply this, you're going to multiply that one. You're going to multiply this one. Remember, these are all multiplications. After you do that, hit division. So hit the division sign. And then I highly recommend this. Put a parentheses squared in your calculator because this helps the calculator understand the PIMDOS that you're using because the calculator doesn't know what you're doing. And then you should get this, and I want you to make sure that you freeze this before you check the answer. Just make sure you're confident because on the homework, you have to be very precise here and round off a little bit. I think you're gonna round off to like 3 decimal places. And what you're gonna pop up is that remember you're mentioning the force between the two charges, the force, and so opposite charges attract. So you know darn well that this was positive and negative. So that means they are going to attract each other with a certain amount of force. So if you think about it, if you have if these were like a string, let's say you had a string, and these were two strings, and these were the electric charges. So if this had a positive charge and this had electric charge, you know darn well that these are going to kind of attract each other. But they're not going to attract each other so much because that is not a very big number. If this was a huge number, these things would be like, "Hey, I want you as very close as possible and very a lot of pressure." But that's not very much uh, force on these. That's not so they're kind of like maybe doing this. They're kind of like nudging. They're like nudging a little bit. They're nudging a little bit. And if you as by the way, if you think about it, if you take the two objects, they're coming closer, right? But if you move those objects away, what's going to happen? They're going to get less. So if you move them away, what happens to the force? As these objects move away, what happens to the force? It becomes smaller. So as these climb, that force is going to get less. That force is going to get less. And as these two objects come closer to each other, this is going to climb. I hope that you kind of see the application of this and not just like, I see the numbers and it freaks me out. No, I want you to kind of say as the two electrical charges, remember, the electrical charges have these on them. These don't change. These are not going to change. So here they are. And as they come closer, the force of attraction is so much more than they are, right? But if they move away, you get less attracted. And that's what we talked about with Newton's law of gravitation, right? We had a homework on that. As we put the two masses together and they put smaller distances, they're going to have greater force. But as soon as you move them away with different masses, obviously, they're going to be a lot less force. Okay, so just get that idea down, and you will be fine with this. And don't overdo it. Okay, so let's give you some more here because the more you do, the better you're going to get at this. So why don't we take? Let's see here. Let's take a balloon sticking to a wall. So we talked about this in the last lecture that if you take a balloon, here's your head, crazy hair, like me, and if you take a balloon and rub it to your head, it sticks to a wall, right? And here's the wall. It's going to stick to the wall because you're transforming electrons around. And so let's talk about this then. So let's say that I have Q1 and Q2. Q1 and Q2. And Q1 has this much negative charge on it, and Q2 has a different kind of charge on it. It looks very small. They're both small, but they change by a negative and a positive. And so you're always having some information here. You have to have a D because the D matters how close they are. And so this is not very big. I hope that you understand this one from this one. Look at the decimal. This was, what was it, 50 centimeters? This is hardly nothing. So you're very close to the wall, very close. So please stop the video and take the equation that we did and make sure you get this. And I hope that you see the reason this thing is so much bigger than that one is because this is sticking to a wall. This has enough force to remember gravity. Gravity is a factor always, right? Gravity is that was it 9.8 meters a second is always affecting objects. So if you think about it, why does a balloon stick to a wall? Well, if you think about it, it has to fight gravity too, because gravity is always going to be pushing down on that balloon. And so that balloon is sticking to that wall at the same time fighting gravity. So this is one of the reasons why this has to be so large to fight gravity. So this has to be kind of like very larger for G, because why it sticks to the wall. If this was less, so let's say that the force was less, you know what's going to happen, right? That means the thing will fall down. This balloon does not have enough static friction, and that static friction is going to be overpowered and then fall to the ground. So I'm hoping that you will take some time, put this into a calculator and get this number. And here's the equation up here, kind of the process. And you might need to go back to the notes, and I think it's right here, right? So that's F equals K. By the way, a lot of students get kind of freaked out with this K because they don't know what to do. But if you go back to it, you can actually do it this way and go K times Q1, Q2, and then D squared. So so you can multiply the K at the top and just divide that whole thing by D squared. So you can multiply the K times the Q1 times Q2, and then divide that by, remember, put that parentheses in there. It helps with the calculator. So please make sure you understand that part and get this answer, because on the homework, I don't want you kind of freaking out and say, well, I didn't get the homework, or I didn't get the problem. So here's the summary of this. And then maybe we can do one more here before we go here. Coulomb's law says explains forces behind electric fields. So remember, we're still talking about electricity and magnetism working together. Particles in current levels is kind of what's going on. One electron, I don't know if you know about this, but one electron does have a certain mass. Remember, everything should have a mass to it, because mass makes things attract to each other. If you didn't have mass, you can't attract to somebody. So you might want to know this a little bit, but like I said, it's up to you. I would like you to kind of know a little bit about, everything has some kind of mass. But one electron is, you can't see electrons, obviously. Remember, electrons are around the nucleus of the atom, and they have a little bit of a charge. That's why they can kind of stay in contact. That's why they're floating around the center here. And if they have a little bit of mass, these two are attracting each other. The nucleus is attracting the electron. And so that's why your atoms don't fly apart unless they have something different to them, though. So they maybe put a charge on that. Okay. So I want you to try maybe a little worksheet with me. And before we go, and so I want us to try this one together. Okay, so let's try this one together to kind of make sure it works, because I want you to think about this. Now, I want you to also understand that you might have to take this equation you might have to take the Coulomb's law and solve for Q2. You might have to solve this for a Q2. So let me show you this first before we do this problem. On the homework, there are going to be a couple questions. There might be hard for you. And I know math is sometimes tough for people, but what if I'm given everything? I'm given the force, I'm given the distance, I'm given always the constant. Maybe I'm given the static charge of one, but I want to find the static charge of the second. So what you're going to have to do is do a little bit of rearranging. So let me show you how to do this, because you're not freaking out on the homework here. So let's take our equation that looks like this, and let's solve for this Q. okay? So the first thing to do, why don't we get rid of the d squared, the division? So remember how to get rid of the division? You multiply both sides. So if I multiply both sides by d squared, I get f times d squared equals k q1 q2. Okay, so I multiply this side, but what I do to one side, I multiply the other side. What am I looking for though? I'm looking for q2. I'm looking for this guy right there. So I have all these multiplications, but I want this one to be left here. So what do? Well, I take a division and I take k away and I take q1 away. But what do I do to one side? I have to do to the other side. And when you do that, these go away. You get q2 because cross cancel, and you get that. So on your homework, you may have to show this because I want you to try to calculate one of the charges because you're trying to determine if it's how much charge you're trying to. By the way, what you're trying to do is that you're determining one of these. So let's just say, for example, Q1 was a positive, and then how do you know if they're repelling or they're attracting? You need to know what Q2 does because that will determine, hey, do I attract each other or do I repel each other? And that's something that you're going to have to figure out. You might have to watch this video again. So if you take a look at this one here, and let's go ahead and do this one, and then we call it a day on this. We go from there. So here's the answer, and I want you to try the answer, right? Let's say the answer, I calculated, I got a really terrible number here. And so I want you to have it. This is the number there. That's the force of attraction. Okay, so to kind of throw this at you, and I want you to put this, make sure you read all this information. So a negative charge particle has this, a positive charge has this, separated by 80 meters. What's the force on the charge? So make sure you kind of show your work. Here's the K. If you want to put it like this is fine. I think the K was what, 0.09 times 10 to the ninth, I do believe. All that. Now, what's Q1? Well, Q1 is, hey, you have a negative charge, so why don't we just call it that? And then you have another charge, which calls that, and then they're separated by 80. Good. And then there you go. Okay. So take a little try with this. Rewatch this video again. I'm hoping that you're learning some stuff and hopefully doing the homework correctly and go from there. All right. All right, everybody. See you when I see you.